When we get to polyatomics, I switched my pen, I think this one's better. Polyatomic ions. Poly, like polygon, means many. Polygons are many-sided objects. This is polyatomic, many atom ions. Well, an ion has a charge. So something that has many atoms and a charge is still an ion, but it's different. So sodium is not. Sodium we have seen. Sodium has one electron, which will go somewhere else, resulting in a sodium ion. I'm going to use brackets still for now. Hydroxide, well, it's got the IDE, and the IDE normally tells me that that was a substance that's got a name change. So I would look for a hydroxygen or a hydroxygyne or some sort of thing with INE. It doesn't exist. You're not going to find that because hydroxide is a polyatomic ion, and the way that you find those is you look on your periodic table and there's a list. So if I look on my periodic table, I find out that hydroxide is OH with a 1 minus charge. For consistency, I'm just going to draw it like this. And what I have to do is figure out how many of each. Now again, drawing the dots doesn't really work because you haven't got to Lewis structures yet and some other things in chemistry. So let's just deal with the pluses and minuses. We know this compound has to be neutral, which means the pluses and the minuses balance out. One positive charge from sodium and one negative charge do cancel out, and so my formula is very simply Na plus OH minus. That is what it's going to be. The name of that is sodium hydroxide. The formula, I write it exactly as there. I have one Na and I have one OH group. This whole group is 1 minus. Now, a lot of people want to put brackets on this. If there's a 1 in chemistry, so we want to put brackets. If there's a 1, we drop the 1. We never write 1s. We drop them. And if I drop the 1, I don't need the brackets because that is a group. We'll look at one in the next one that does actually need brackets, so we'll look at that now. This is a more common example, as you'll see. Typically with polyatomics, we'll get an ending of ATE or ITE. The last one we saw, hydroxide, it's a weird one. The other one to note is ammonium. So that's an EM and the other one's an IDE. Those are pretty common, you'll get used to them. But most of our polyatomics have the ending ATE or ITE, which we'll see a little bit in acids and bases why. For now, we just got to recognize ATE and ITE polyatomic. When I have a formula, however, I don't have a name. I have to recognize from the formula, and here we see I have some brackets here. The brackets are telling me that that is a group. The NO3 is staying together. That's bonded together. That thing is a group. It's staying together. And the little 3 outside the brackets means I have 3 groups of NO3. And let me erase this here, give myself some more room. I have 3 groups of NO3. That's what that little 3 is telling me. Everything inside the brackets, I got 3 of them. So I have NO3, 3 groups, and I have 1 aluminum. Now, aluminum, I can look at my periodic table and it tells me it's 3 plus, or I can realize that it was in group 13, so I lost 3 electrons, presumably to each of these nitrogen or these nitrate groups. I'm going to end up with aluminum with a 3 plus charge, however you figure that out. But nitrate, I don't know what the charges are on nitrate, so I look it up on the periodic table, and in my polyatomic ions chart, I see that each one of those is 1 minus. So what must have happened is each one of the electrons on aluminum must have somehow gone into these groups, and I'm not exactly sure how because I can't draw it, but that must be what happened. So 1, 2, 3 got divided out the same way it did with chlorine or bromine or fluorine. So I end up with Al3 plus, and I'll just change these from circle brackets to square brackets for consistency, and I have 3 nitrates. And so that works out really well. I have 3 minus charges here, I have 3 plus charges, balances out, neutral. So these two are fine, and now I need to name it. Well, that's an aluminum ion, or aluminium. An aluminum ion, and this, when I looked it up to find the charge, was called a nitrate, and we don't change the name when we're naming polyatomics. They just stay whatever their name was. Aluminum nitrate. So we just have to recognize what the brackets mean, what the groups mean. It means that that whole group of atoms together has a 1- charge. In the same way, let's say a fluoride, which was just by itself, has a 1- charge. And they mean the same thing. They mean the same thing, except this is a group, polyatomic.